So Alex, we were just talking about this transformer here, and just correct me if I'm wrong, is it dedicated for this particular site?
It's not dedicated specifically for this battery site, but it is shared between Southern Plants and this battery.
So what we're talking about is a pad-mounted transformer. So a lot of the guys would be, and the general public will be seeing transformers that are pole-mounted. But obviously the size of this transformer, you're never going to stick it on a pole, are you, 2 MVA?
It's not possible. It has to be on a concrete slab.
From the idea of spatially, we're talking about the transformer being very close to the, and what would you call this, the meter?
This here
What's
is more
it
of
technically
a,
called?
well, I'd call it a kiosk.
Kiosk?
Really, it's a distribution board for United Energy. So this board allows them to previously connect generators on site to their board and have control over it, which is why this transformer is the size it is on this site.
So when you're saying generators, are you talking fossil fuel?
Yes.
A diesel gen set?
That's correct. So during the summer, tourist season down here on the peninsula, they have power stabilisation issues.
Okay, so we're here at the, I suppose, the inverter station section of this particular project. So we're talking about a BESS system. We're talking about 10 inverters. Alex did correct me, I said 8 before, but there's actually 10. Now, just tell us about these inverters, Alex. What are their specs? What's the scenario?
Well, these inverters are 100 kilowatt each. They are capable of charging the batteries at about 157 amps at a time.
Yep.
So there's a lot of power that can be pushed through 10 of them, through to these batteries. As you can see, we've got 2 sides, which is actually 2 separate systems. So 5 inverters make up one system, and they're connected to 3 batteries.
Yep.
And these 5 are connected to another 3 batteries on this side.
Okay, but all up, how many batteries are we talking about? I thought there was a few more than that.
Well, this site, because of the 2 NMI situation, this is 1 NMI, has 10 inverters on it, whereas the other one has a further 2. So there's 12 inverters on site.
All up 12 inverters.
All up,
so
which would bring this site to 1.2 megawatt of inverter power.
Right, okay. Now the battery storage component here, like cumulative, what are we talking about in megawatt hours?
Well, each one of these cabinets is 331 kilowatt hours storage.
331?
Yep.
Unusual number.
It is a strange number.
It is a strange number.
I thought that myself. So there's 6 of those. And then down the far end over there, we have a further 2, which is on the separate NMI.
Right.
And those 2 are 250 kilowatt hours each.
Right, okay. So these, and for those guys out there who are mostly doing solar kind of job, there's no solar on this site at all. These inverters are specifically dedicated to the battery, to the particular battery bank that they're connected to. Now, if we come down, maybe down here, your neg here and you've got your pos here, and you can see by the heat shrink, the colour of the heat shrink. Now there's a perspex cover here, obviously, because from a protection touch voltage perspective. And now we've got the phases, we've got the red, white and blue, and then we've got the neutral here. Can you just explain what's going on in this section over here?
So that board there is basically the control board for the inverter.
Yep.
It interlinks to each inverter so they can all talk and operate as one system. So all 5 of these inverters will be connected together, daisy chained, and they go back to a site manager which will operate all 5 inverters as one unit.
Are they the HRC fuses?
Yes, there's HRC fuses on the AC and DC connections.
Right.
To protect both the installation and the cabling.
So these particular inverters have, as Alex has pointed out, forced air cooling, but they don't have an HVAC system like the batteries do. Now, obviously, this is the inverter here behind this.
Which makes them rather top heavy. So the inverter is mounted in the top section of the unit, which is good for heat on the actual control gear, so it keeps the control gear nice and cool. Okay. But it does make them top heavy when you're moving them around.
And then right next to this particular inverter, and this bank of inverters, is one of the battery cabinets.
That one there is a battery connection panel. So that's basically control gear for all of the batteries and the inverters.
Can you point through the components, starting from the the golden shield.
Yeah, so the golden shield up here is the manager of the equipment. It controls the batteries and the inverters. Basically, you could run the system with just that site manager,
Yeah.
but we are connecting it to another site manager which will do more than it can.
And you were saying before that it's directly controlled by...
BESS controller, that's what it's called.
It's a BESS controller.
Yeah, so this golden shield is a BESS controller which can control the batteries and the inverters to make sure they all operate when required and how required.
The distributor in this particular situation has control over this site?
They'll have control over this whole site, but not directly through this BESS controller. This BESS controller will connect to a site controller, which will allow the distributor to control each unit.
Right, interesting. Now, this box over here, this you was mentioned...
This is a UPS system, which will keep the controls for the BESS, the inverters, all in operation if there was a power out at all times. So they can safely shut down or just pretty much see what's going on site.
And obviously when power resumes, the UPS gets charged back up automatically.
Yep.
And I'd assume they're using, a lithium iron phosphate battery or something similar within the UPS. Yeah, right, a bit of lithium battery, yeah.
Yep.
So, and we've got, what about over here, over this section here?
This is a contactor. It is for the UPS so that it will switch between grid supply, which is fed from down here,
Yep.
or pretty much disconnect that on a UPS situation. Just for safety measures, they put that in.
And the actual, this LED screen or LCD screen?
This here is a fire indication panel. This is connected to all of the batteries, so if there's any problems inside the batteries, they all have their own fire smoke detector and fire suppression system, which will trigger the fire indication panel. These will be interlinked to a mains fire indication panel because there's 3 of these on site, so if any of them trip, it will contact the fire brigade of the local area. Going down the components over here, this one here is the battery management system.
Yep.
This talks directly to each battery and communicates back to the golden shield. So all the batteries communication goes through the battery manager,
Yep.
and back up to the BESS manager.
Yep, right.
Which is the whole site. 12 volt power, 24 volt power supply is just to power the router here. This is an unmanaged switch.
Okay.
This is where everything plugs in. So we've got the inverters, a daisy chained out of here.
Sorry, what do you mean by an unmanaged switch?
This unmanaged switch, it doesn't assign IP addresses itself. It needs to have another modem that takes precedent over it. So this will be connected back to our main control gear, which will direct the whole system as to what to do. This one here is just a power supply, 24 volt, which will power the unmanaged switch.
Gotcha.
That's all that needs to do. It also puts 24 volt up to control this relay. It's part of the control gear for the system.
Now, we're coming down to the bottom of this cabinet. Obviously, there's a large piece of perspex covering everything.
Perspex is there for touch voltage because there's no other way to protect the main bus bars behind there. This is where this kind of system is different to a lot of other BESS systems. The way that this battery connection panel connects to the batteries is via a 100mm Busbar that goes directly from chamber to chamber, all the way along the bottom.
Oh, so there's an unbroken Busbar going all the way through.
All the way through. So it goes from here down 3 cabinets, all through each battery.
And it's actually, so basically there's a hole in the side of the cabinet. Now, what's the material? What is that black material there that you're touching?
This is a rubber diaphragm they've given us from Ryzen that actually is weather sealed and screws in between the cabinets. It creates a nice pathway.
Right.
It's like a rubber accordion that just separates between the 2 cabinets.
Right.
So it just screws in and it gives you a nice pathway, which is good because we've got the main 100mm buzz bars that run between cabinets, as well as the equipment. The power for the HVAC on each unit is supplied from this battery connection panel.
And what kind of current are we talking through those bus bars? Approximately.
Well, each battery has the ability to charge or discharge at 140 amps, and we've got 3 of them.
Yep.
About 420 amps.
Now, unlike the inverter cabinet with the fan-forced airflow situation, this has actually got HVAC in it.
Absolutely.
And it's both cooling and heating?
Yes, it'll do both. So to maintain as best to its ability the temperature inside the cabinet at a desirable temperature. Down here you've also got these cables here are the main connection from the battery connection panel off to each inverter. So each cable, one's connected to positive, one's connected to the negative, and they come off the main bus bar
Yep.
underneath into a concrete trench that we have underneath all the units,
Yep.
and then back up into each inverter. So this is one of our battery modules. As you can see, it does have independent modules within, which make up the full compartment. Each battery module itself is actually about 40 volts, but once they're connected together, you end up with 1300 volts.
And so obviously the batteries are series and paralleled?
These are all just series in here, so
Okay.
the battery cabinets themselves are run in parallel, but inside each cabinet they run series. So each battery will have the possibility of putting out 100 or charging or discharging by 140 amps at about 40 volts.
Okay, so let's reiterate here. So we're talking each cabinet, it's simply a series connection between the battery cartridges, modules, whatever you want to call them, and then each individual cabinet is then paralleled up to get that higher current.
Correct, they're actually paralleled down here. As you'll see, you come out of the bottom of the main isolator here. These two cables connect onto the buzz bars that run through the bottom and out into the next cabinet.
And you can see here that unbroken bus bar that Alex was talking about running from the cabinet we just spoke about before.
Yeah, so they run from the battery connection panel through to the first battery, then out to the second, and then so on to third, fourth, however many batteries you have. In this case, we have 3 per battery connection.
What are the two? Are these? Is this some kind of door sensor thing? What
These
are
ones
they?
here?
Yeah.
So all of the battery connection panels and the batteries themselves have these door switches. So if any of the doors are to be opened, it'll de-energize the system immediately. Likewise, if there was an explosion in here, it'll push the doors off their hinge, which would disconnect everything.
Yep. So you were mentioning before, Alex, about the actual HVAC, and from a design perspective, can you sort of elaborate there?
Yeah, it's really one of the only locations you could put it on this unit, but it does hang off the door. So this is the HVAC unit for this battery, and it pretty much will circulate air through this duct, into that duct, and then down around all the cells.
When you say that, couldn't it have been put on the back of the unit?
It could, but the back of the unit is reserved for servicing. So there's actually screws on the back to remove to get to the back of the system.
Gotcha. So behind the batteries here, there's a space. Yeah. Okay.
And
so
these
that
cabinets
makes.
themselves are already 1400 deep.
Now, this obviously is the control panel for the HVAC.
Yes.
Can the settings, both heating and cooling, be changed remotely?
Yes. So these HVAC equipment is connected back to the unmanaged switch in the battery connection panel, and that connects back to the golden shield, which will be able to change the settings on each HVAC equipment.
And who has authority, or who will have authority to change those settings?
So that won't be able to be changed by the distributor.
Okay.
That will only be able to be changed by the system owner.
Yep.
They will have access to change that either on site or remotely via the site manager.
Okay, I noticed this is the MEN link here. And can you just run us through the cabling? What have we got? What's the cable capacity here?
So those cables there are 150 millimeter cable.
Yep.
They will supply 4 of the inverters on site.
Yep.
And yeah, the MEN link is inside this cabinet with the main earth connection.
And obviously this is XLPE cable, because that's what
This
we.
is 110 degree rated. It's
Ah.
all fire rated to get that extra, little bit of extra rather than going up cable size.
Yeah. So what Alex is what Alex is talking about is, in some cases, the physical size of the cabling from an installation perspective, getting it through conduit, can really play havoc. So by going up to a sheath that has a higher temperature rating, the current carrying capacity can actually increase, because at the end of the day, copper is not going to melt unless it's subjected to some very hot temperatures, and the current carrying capacity of cable is due to the ability of the insulation to dissipate the heat.
Yep.
So this is 110 rated as opposed to a 90 degree.
Yep.
Yeah.
So it's only an extra 20 degrees, but that makes a difference to our current carrying capacity to the point where we don't need to increase the cable size.
That's fantastic. And what about from a cost perspective?
Going up cable size is usually more expensive than going up cable temperature.
Right, very interesting.
And in this case, derating on the cables is inside the pits, where we have all of the inverters go through the same pits.
Gotcha.
So there is a pit behind this board that has all cabling for all 12 inverters go through it.
Wow. Okay, moving on to, we've got the section up here which is the meter, and you can see the signage here, energy storage, and there's a UN number, and that number 3480 correlates with the kind of battery storage chemistry that's being used on this site.
This is one of the 2 NMIs that are on site. So the mains cable will be unmetered until it reaches this board, and from this board we have 2 separate NMIs. This is one of them. So this one is the meter for a 2500 amp main switch.
So here we've got this cabinet, this section, it's inverter isolators with some numbering. So we've got, there's a 250 amp isolators, and they're set to 212. So this is a circuit breaker, isn't it, here?
Yes, this is a circuit breaker. This is the circuit protection for the cabling. So inside the inverters we have isolators.
Yep.
With no circuit protection. The circuit protection is offered here at the main board by these circuit breakers.
So can you quickly, for the people who don't know, sort of explain the difference between an isolator and a circuit breaker, and when?
An isolator has the capability of disconnecting the load at a specific current. So they've got 250 amp isolators inside each inverter. If you do turn it off, it will disconnect the load. However, the circuit breaker gives you short circuit and overload protection.
So, which an isolator doesn't do.
It doesn't do. So it has the capability of manually being switched to disconnect the load, but it won't do it automatically. Whereas a circuit breaker, it has thermal strips inside that once they get to a certain temperature, trigger a spring that disconnect the load.
So, okay, the connections to this particular breaker, they're not cable. They seem to be some kind of flexible...
Yeah, so these connections here, this is a flexible buzz bar.
Okay.
So this makes it easy to connect to the buzz chamber.
Yes.
And through wherever those buzz bars are without having to get bar work bent up.
Right.
So flexible buzz bar is incredibly useful in areas where the bar may have to bend around corners.
So we've got a 250 amp breaker, and we've set them to 212 amps, and the reason sometimes that we do that is so that that allows us to use a particular cable that has a lower current carrying capacity than something that was required the full 250 amps.
Most of the time these breakers come in sizes. 250 amps is the step above. They don't really come in a 212.
Correct.
So to get that capacity, we just change the settings down the bottom here.
Just tweak them down, we dial them down.
Dial them down.
But that allows us also to use, say, for instance, a cable that has a current carrying capacity of 220 amps.
Correct.
And if we left the setting at 250 amp, we'd have to use a cable that's 250 or greater in regards to current carrying capacity. So it can be an economic decision as well. So there's 4 of these, and that's for the 4 particular inverters in this situation here. So effectively what we're looking here is the busbar zone with the door removed. Obviously there's nothing live on this particular site. And the inverter isolators, so this is another set of inverter isolators, 2, 4, 6, 8 of those.
2 of them down the bottom are actually for the battery connection panels. Those power the HVAC equipment on the batteries.
I can see the 50 amp set to 50 amps, right? Yeah, gotcha. So there's six inverters and 2 for the batteries. Right here is the cabling zone. Busbar zone is above. Now the main switch.
This is the main switch for this NMI. This is a 2,500 amp ACB.
So we're talking a very substantial circuit breaker there. 2,500 amps set to 2,050 amp. Yeah, okay, that's very precise. Very precise.
Very precise. These breakers are very precise, and they have the ability to be controlled remotely. So this will also be connected back into the site controller.
Wow.
Yeah, this chamber here is one of the most important chambers of this board. This chamber is one that is shared with a lot of PVDBs in the gear that's inside it. It does contain a grid protection relay behind the scatchum here, and relays to turn on and off the breakers should any of the requirements not be met.
Yep. Now, you were saying before that there's particular, the bus bar zone down here, it's locked. Eventually, when everything's finished, it's locked off completely. Never gets open. But what, unless there's some kind of emergency or dismantling. But let's talk about this large cabinet here. What's going on? What's behind there?
This large cabinet is our incoming supply, so it has 16 630mm cables.
They're sort of the biggest really that are around, or do you get bigger cables?
You can get larger, but the regulation books don't have much information on them, so you have to go off the manufacturer's specs for anything larger than that.
Oh my gosh.
630mm cable has a large current carrying capacity. As you see, we do need a lot more than what that offered, so we've had to run 4 of these cables per phase.
Wow. 4x630, so 4x630 SDIs per phase, and we've got 4, obviously 4 we're matching on the neutrals.
Yep.
Wow, now, as I was saying before, that's a lot of copper.
It's a lot of copper.
It's a lot of copper.
As you see, we've padlocked it.
Yes.
So the unique thing about this supply is it will be unmetered from the point of connection at the board down there up into this board.
Wow.
So point of supply all the way through till the metering transformers, which are here.
Wow.
So this connection will supply the bus bar above.
Yep.
And then we'll come down either side through an isolator.
Right.
And then down through metering transformers and across to the main switches.
Wow. Very impressive. Now we're coming to the last section. So we're talking, so that's an 800 amp isolator there.
This site has 2 separate NMIs. One side is a 2000 amp supply, the other side is an 800 amp supply. So this is the smaller system. It contains 2 inverters, not 10.
Yep.
So that's 200 kilowatts of inverter power and 500 kilowatt hours battery storage.
What's the last little cabinet there?
This one here is the battery connection panel. Like we had over the other side, it has a 50 amp breaker.
Oh, okay.
This powers the HVAC equipment and the control gear within the battery connection panel.
So it has a dedicated enclosure within this enclosure.
If you think about it, it's more like the cooling and heating and cooling and controls.
So we're almost at the tail end of this project. What was the biggest thing you've learned about this particular project? You know, like, was it a learning experience? I suppose it was, but what stands out in your mind about this?
In my mind, a unique thing about this project compared to other battery projects we have done is the fact that every cable is underground. So all of the conduit works. Underneath this concrete slab is 80 conduits that connect all the cabling to the equipment without it being seen anywhere.
So it results in a very clean installation, doesn't it? Like you're effectively seeing these cabinets and there's no cable, all the cable's hidden.
There's no cable tray, there's no cable, there's no mucking around. It's nice, crisp and clean.